What if I told you the exact price tag on your life? Like, depending on which scientist you ask, the actual chemical elements making up your physical body are either worth a measly $168 or over $150,000.
Yeah, it's a massive discrepancy. I mean, honestly, that gap tells us something pretty profound about how strange and, well, unpredictable human biology really is when you try to just break it down to its raw economic materials.
Right. So, welcome to this deep dive into your source material. We're looking at the literal blueprint of you today. And this whole price discrepancy thing is, I think, the perfect starting point because it really highlights just how little we actually appreciate the atoms that are keeping us alive.
Absolutely.
Like, we aren't just looking at fun trivia today, we are really breaking down the mechanics of the cosmic scale machinery operating silently inside you right now.
Yeah, because once you understand the actual physical mechanisms, how these elements assemble, how they function, without any sort of central control, and just the sheer scale at which they operate, it fundamentally shifts how you view your own existence.
Wow.
It's essentially a hidden blueprint for understanding what it physically means to be alive.
Okay, so let's unpack this price tag thing first. Because the history of trying to put a monetary value on a human is, honestly, it's fascinating. The source material outlines a few historical attempts to calculate this.
Right.
Like the author mentions being in junior high school in the 1960s, and his biology teacher just casually told the class that all the chemicals in a human body could be bought at a local hardware store for about $5. Just, a $5 walking chemical sack.
Which is a pretty bleak thing to hear as a teenager.
Obviously.
But that $5 figure was largely based on the fact that humans are mostly water, carbon, and a few really common minerals.
Right.
Fast forward to 2012, and the PBS science program NOVA did a much more updated analysis, and they came up with a figure of $168 for the fundamental components.
Which is still not exactly a luxury price point,
No, not at all. But then, just a year later, in 2013, the Royal Society of Chemistry in Britain decided to do a much more rigorous, comprehensive calculation for the Cambridge Science Festival.
Oh, right. And they didn't just throw out averages, did they? They used a highly specific template.
They did, yeah. They used the actor Benedict Cumberbatch, who actually happened to be the guest director of the festival that year.
That is amazing.
Right, so they calculated the exact cost to assemble all 59 elements necessary to build one typically sized Benedict Cumberbatch. And, because it's the Royal Society, they priced out only the absolute most highly purified forms of every single element.
And their grand total for a pure hardware store Benedict Cumberbatch, a highly specific $151,578.46.
Yep.
They even noted that once you factor in, labor and sales tax, you're looking at a take-home human for about $300,000.
Which is quite the jump from $5.
I mean, let's actually look at the receipt for this, because the breakdown is bizarre. You need 59 elements, 6 of them. So carbon, oxygen, hydrogen, nitrogen, calcium, and phosphorus, they make up 99.1% of what makes you, you.
Right, the vast majority.
And the biggest component by volume is oxygen, taking up 61% of your available space. Now, this is where I actually need some clarification from you.
Sure.
Because oxygen is an odorless, weightless gas. If we are nearly 2/3 gas by volume, how are we not just, floating away like helium balloons?
Okay, so that's a really common point of confusion. The oxygen inside you isn't just floating around freely as a gas. The vast majority of it is tightly bound at the atomic level with hydrogen, which, by the way, accounts for another 10% of you.
Okay.
And they bind together to create H2O, water.
Water.
Right. And water is incredibly dense and heavy. So, ironically, 2 of the lightest, most volatile gases in the universe chemically bond to form the heavy fluid that actually weighs you down.
That is so wild. But economically speaking, those elements are an absolute bargain. Like, for a Cumberbatch-sized human, all that life-giving oxygen will only set you back $14.
Which is crazy.
Your hydrogen is roughly $26. Nitrogen is 40 cents for a whole body's worth.
Yeah. The real budget breaker there is carbon. You need about 30 pounds of carbon, and according to the Royal Society, highly purified carbon will run you almost $70,000.
Wow.
And then calcium, phosphorus, and potassium add another $73,000 or so, and then you finally get to the trace elements, where the pricing is just all over the place.
Yeah, like you need microscopic amounts of thorium, which costs over $3,000 a gram. But since you only need 0.0000001% of it, your total thorium budget is basically 33 cents.
Exactly. And samarium is valued at exactly $0.
Yeah.
And, we can't forget the hitchhikers. You have elements inside you right now that serve no biological purpose whatsoever and are actually toxic.
Wait, really?
Oh, yeah. Cadmium, for example, is the 23rd most common element in the body. It makes up 0.1% of your bulk. We completely don't need it, but it exists in the soil, which means it gets into the plants we eat, and it eventually just settles into our tissues.
Okay, I mean, I have to push back on this whole pricing exercise, though. Calculating the value of a human by looking up the spot price of carbon and oxygen, it just feels entirely backwards to me.
How so?
Well, it's like trying to price the Mona Lisa by throwing the canvas on a scale and weighing the paint.
I see what you mean.
You can say, oh, well, the wood panel is worth $10 and the oil pigments are worth $20, but it totally ignores the architecture of the masterpiece. The value isn't in the paint. It's in how the paint is arranged.
Yeah, that is exactly the point. And honestly, it's the ultimate takeaway from the Royal Society's stunt. It proves the total absurdity of reducing biology to a parts list. Right.
Because no matter how much money you spend or how carefully you source the purest carbon and calcium on the market, you cannot buy a human being.
You really can't.
You could put the most brilliant scientists on Earth in a room, give them unlimited funding and the sum total of all human knowledge, and they cannot assemble those raw elements into a single functioning living cell.
Let alone a fully formed person.
Exactly.
So, if this macro-level parts list is basically a dead end, we really need to look at the architecture. Like, what is actually happening at the micro level with these cheap gases and expensive carbons?
Well, to understand the architecture, we have to look at the mechanics of how these elements are managed. The physical machinery operating at the cellular level is incredibly precarious. So let's look at one of those trace elements. Let's take selenium.
Okay, selenium. According to the source material, if you pluck almost any cell from your body, it has 1 million or more selenium atoms inside it. 1 million atoms in a single microscopic cell. Right. And what's astonishing is that until relatively recently, scientists had no idea what those million atoms were even doing.
They just didn't know.
They have no clue. They were just sitting there, completely unaccounted for in our biological models. But now we know they are responsible for making 2 extremely specific, highly vital enzymes.
And just so we're all on the same page, an enzyme is essentially a biological catalyst, right? Like a highly specific chemical wrench that either forces molecules together or breaks them apart.
Exactly. Enzymes speed up chemical reactions that would otherwise take years to happen on their own.
Yeah.
Without these selenium-based enzymes, crucial biological processes would just completely grind to a halt.
Wow.
But here's the mechanism that shows just how delicate this operation is. The body is walking a microscopic tightrope.
Okay.
If you don't have enough selenium, that deficiency is directly linked to hypertension, arthritis, anemia, and even certain cancers. You critically need it, and you absorb it from things like nuts, whole wheat bread, and fish.
Okay, so eat lots of selenium. Got it.
Well, hang on. Because if that cellular machinery tips too far the other way, and you take in just a little too much selenium, it becomes highly toxic and will irremediably poison your liver.
Oh, wow. Okay, this is where it gets dizzying for me. If the margin of error between vital health and literal liver failure is that small, the logistics of managing it are terrifying.
Oh, absolutely.
How does the body even know? Because I'm definitely not tracking my atomic selenium intake when I eat a piece of toast. Why does this matter to me on a daily basis?
Well, you aren't tracking it, and frankly, you physically couldn't if you tried. The mechanism here relies entirely on autonomous systems operating completely below your conscious awareness.
Thank goodness.
Right. When you chew and digest that toast, your digestive tract chemically strips the selenium from the food matrix. Your circulatory system acts as a highway, and specialized proteins actually bind to the selenium to transport it.
Like little Pargo treks.
Exactly. Then, specific receptors on the surface of your cells recognize these transport proteins, pull the selenium inside, and distribute exactly the right number of atoms to synthesize those chemical wrenches we talked about.
And what happens to the rest?
All the excess is filtered by your kidneys and expelled. This highly choreographed industrial supply chain happens while you're just sitting there, completely oblivious, scrolling through your phone.
Man, if managing just 1 million atoms selenium in a single cell is that precarious, the mathematical nightmare of scaling that up to a whole human body should mean we are just constantly falling apart.
It really should.
The sheer amount of physical material the body has to govern is hard to even visualize.
It is. I mean, once you move from the microscopic cell to the macroscopic body, the numbers literally stop making intuitive sense. To build you, it requires 7 octillion atoms.
7 octillion.
That is a 7 followed by 27 zeros. 7 billion atoms, all precisely arranged.
And if you physically unpack those structures, the dimensions get surreal. Like the deep dive mentions that if you were to somehow smooth out all the microscopic air sacs in your lungs, the surface area would cover a full-size tennis court.
Yeah.
And the blood vessels inside you. If you laid them all end to end, they would wrap around the Earth 2.5 times.
It's unbelievable.
What?
But honestly, the physical scale of your DNA is perhaps the most difficult to comprehend.
Yeah, this one is staggering. You have about a meter of DNA packed into the nucleus of almost every single cell.
Just in microscopic space.
Right. And to fit a meter of material into a microscopic cell, the DNA is coiled around these special proteins called histones. It's tightly wound up like an infinitely complex spool of thread. But if you took all the DNA in your body, unwound it, and stretched it out into a single incredibly thin strand,
Guess how far it goes?
it would reach 10 billion miles. That stretches past Pluto and literally leaves the solar system.
Think about that for a second. You possess enough geometric complexity inside your own skin right now to physically exit the solar system.
But here's where it gets really interesting. Here's where we hit the philosophical wall for me. Those 7 octillion atoms, the ones stretching past Pluto, they are exactly the same inert elements you would find in a pile of dirt.
Yep. Just raw material.
A carbon atom inside you is physically identical to a carbon atom in a lump of coal. They have no thoughts, no awareness, no life of their own. Yet the great mystery of biology is that 7 octillion, completely mindless, non-living particles somehow have an urgent, coordinated desire to be you.
That right there is the fundamental mystery of emergence. It's the question of where does the physics end and the living begin?
Right.
Everyone agrees the basic unit of life is the cell. But if you look inside a cell, what do you actually see?
Just parts, right?
Exactly. You see proteins. You see DNA. You see ribosomes, which are essentially mindless cellular 3D printers that manufacture proteins. You see RNA, which acts like a piece of transcribed ticker tape carrying the DNA blueprint to the ribosome.
It's just a factory.
Yes. None of those individual components are alive. A ribosome doesn't have a heartbeat. RNA doesn't have consciousness. The cell is just a highly structured little room.
So it's literally just chemistry and physics playing out in a confined space.
Exactly. But somehow, when you arrange all those dead, non-living chemical components in exactly the right physical space, life emerges from the system. Life is an emergent property.
That is wild.
We can map the mechanics of the cell flawlessly, but we still cannot explain that spark of emergence. We are, quite literally, cosmic dust that just woke up and started asking questions about itself.
Wow, it really makes you view your everyday existence so differently. The author refers to us as walking around in this, quote, warm wobble of flesh, end quote. And we just take the sheer engineering of it entirely for granted.
Oh, 100%. We demand so much of this biological machinery and give it almost no credit for what it's constantly doing in the background.
Like blinking. The source material points out we blink about 14,000 times a day.
That's a lot of blinking.
It is. And if you add up all those fractions of a second, your eyes are tightly shut for 23 minutes of every single waking day. You spend almost half an hour a day in total darkness, but we never notice the world going black.
And that's not just because a blink is fast. It's because of a highly evolved neurological mechanism.
Really?
Yeah, when your eyelid drops, your brain literally suppresses the visual cortex for a fraction of a second. It temporarily pauses your vision processing so you don't experience a constant flickering strobe light effect.
That is so cool.
Your brain is basically acting like a live television editor, seamlessly cutting out the bad frames in real time so your perception of reality feels completely uninterrupted.
And while your brain is editing reality, your internal factory is churning out material at a frankly alarming rate. Take red blood cells, for example.
Oh, this is a great one.
Just in the time it takes you to read a single sentence, your bone marrow manufactures 1 million brand new red blood cells.
And the mechanism there is incredibly violent, too. Inside the marrow of your long bones, stem cells are constantly dividing and maturing. They actually eject their own nucleuses just to make more room for oxygen, and then they squeeze themselves out into the bloodstream.
Oh, once they hit the bloodstream, they do not stop. Each one of those million red blood cells will course through your blood vessels, squeezing through tiny capillaries, relentlessly delivering oxygen about 150,000 times.
Just nonstop delivery.
And then, after a few months, when they are battered and physically degraded from all that circulation, they quietly present themselves to the spleen. The spleen acts as a specialized recycling center, identifying the damaged cells, dismantling them, and salvaging the iron to be reused.
It is an entire universe of self-sacrifice and recycling happening inside us.
It really is.
And, what is perhaps most counterintuitive about all of this is the sheer cellular anarchy of the operation.
Yeah.
There is no central intelligence orchestrating this.
Right. I'm picturing it like a massive, sprawling city where there are no traffic lights and no police, but somehow there are never any car crashes because the cars just blindly know where to go. The source material compares it to bumper cars.
The bumper car analogy is a good start, but we really need to upgrade it to understand the actual mechanics. It's not just things bouncing off each other.
Okay, so what is it?
Imagine millions of bumper cars in a pitch-black arena, moving at thousands of miles an hour. But every single bumper car has a uniquely shaped, highly complex magnetic lock on its bumper.
Okay.
They're crashing into each other entirely at random, millions of times a second. But they only stick together, and they only trigger a chemical reaction when the exact right magnetic key hits the exact right lock.
Wow.
It is pure, chaotic physics driven by thermal energy. Yet all this random, mindless, violent motion results in smooth, perfectly coordinated biology across the 37.2 trillion cells of your body.
So there really is no CEO. The brain isn't micromanaging the liver. It's just local chemistry. But, I mean, if it's all just random collisions and chemical locks, how does it not fail constantly?
It's a big question.
Because the sources point out that this chaotic system is also actively fighting off fatal diseases daily, especially when most of us eat junk and sit in front of screens all day.
Well, the error rate is incredibly low, but errors do happen. And that brings us to cancer. When a cell replicates, it copies its DNA. Sometimes that copying process makes a mistake.
The statistic from the deep dive sources that genuinely stopped me in my tracks was that between 1 and 5 of your cells turn cancerous every single day.
Yes. Every single day, a few cells in your body make a critical error and mutate into something that can become a fatal tumor.
That's terrifying.
It is, but this is where the mechanism of your immune system is just so awe-inspiring. First, the cell itself often realizes its DNA is broken and initiates a process called apoptosis.
Which is what?
It's essentially programmed cell death. The cell literally falls on its own sword for the good of the body. Wow. But if the cell goes rogue and refuses to die, your immune system has specialized white blood cells that constantly patrol the tissue. They physically scan the surface of other cells.
Like security guards.
Exactly. And when they detect the chemical signature of a rogue mutated cell, they bind to it and inject toxins to destroy it. Quietly, without you ever feeling a single thing.
That is incredible.
Biologically speaking, cancer is actually a very rare event in the life of an individual cell. Most cells replicate billions of times perfectly. Your body is just a heavily fortified fortress of self-correction.
It's amazing because, honestly, we treat our bodies terribly. We eat ultra-processed junk food. We sit hunched over glowing screens. We flood our systems with cortisol from stress. We don't sleep. It feels like we are committing very slow suicide by lifestyle, but this bumper car anarchy is constantly stepping in and fixing the damage.
It survives our bad habits because it is the ultimate end product of 3 billion years of ruthless evolutionary tweaking.
3 billion years.
Yeah. Every single one of your ancestors, going all the way back to single-celled organisms floating in primordial oceans, survived long enough to successfully pass on their genetic material. There hasn't been a single break in that chain in 3 billion years. Your biology is incredibly forgiving and resilient.
Man, we have covered a lot of ground today. We've talked about the $151,000 grocery list of your elements, the DNA that stretches past Pluto, the million red blood cells born in a sentence, and the invisible wars fought for our survival against rogue cells.
We really have.
So if you had to distill this entire deep dive down for the listener, what is the single most life-changing lesson they can take from this and actually apply to their life tomorrow morning?
I think the actionable takeaway here isn't a diet or a biohack. It's a fundamental shift in your daily mindset.
Okay, a mindset shift.
Yeah, from the moment you wake up tomorrow, you have to stop treating your body like a failing, annoying machine.
I feel like we all do that.
We do. We get so incredibly frustrated when we pull a muscle or get a pimple or feel a wave of fatigue. We view our physical selves entirely through the lens of minor inconveniences and imperfections.
Yeah.
Instead, take a second to recognize the architecture for what it actually is. It's a miraculous 7-octillion atom galaxy that works tirelessly, filtering poisons, destroying tumors, and editing your visual reality, all without requiring a single moment of your conscious effort. Start treating your body with the profound awe, respect, and nutritional support it actually deserves.
Respect the galaxy inside you. I love that. And that brings me to a final, slightly provocative thought I want to leave you with, the listener.
Ooh, let's hear it.
So we started by talking about the price tag of those elements that make you up. But here's the catch. Those 7 octillion atoms inside you right now are effectively eternal. They cannot be created or destroyed.
That's right.
They have been circulating through the universe since the very beginning. Every breath you take contains atoms that once belonged to every person who has ever lived. So you are really just renting this physical material.
Just borrowing it.
Exactly. When your personal cosmos eventually disperses and your atoms return to the Earth, who or what will your atoms go on to build next?
It is the ultimate cycle of recycling. You borrow the carbon and the oxygen, they animate you for a while, and then they move on to the next masterpiece.
So you might just be a $151,000 collection of borrowed hardware store chemicals. But for this brief, highly improbable moment in time, those exact chemicals desperately want to be you. Take care of your 7 octillion atoms today.